Okay, so this is on divisibility tests of 3, 9, and 11. So these sort of are kind of common things. They're a little bit different than another thing. So I've got a number n is divisible by 3 if the sum of its digits are divisible by 3. So let me just do a couple of examples here before we're going to do the proofs of these as well. Okay, show or determine if 7, 3, 6, 0, 2 is divisible by 3, question mark. So 73,602. Okay. So first of all, you can kind of start to see a little bit this might be helpful. Is that, okay, I could again do just the long division on it. That shouldn't be too hard, but it takes a little bit of time. And what we're going to do is, all we do is add up the actual digits. So 7 plus 3 plus 6 plus 0 plus 2. Right? And a couple of things here. Let's see. I got 7 and 3 is 10, and 8 is 18. So since 18 is divisible by 3, then the original number is divisible by 3. Okay. So this is really nice. Again, you should be able to do this a little bit easier on things as well, okay? By your head. All right. So let me also show, there's some other thing, and then I'm going to do the example. What we also say is casting out 3s. What we can do, because, right, if, and this is basically, again, divisibility lemma stuff, is I can look at pieces that are multiples of 3 in here, and I can basically just chuck those out. So for example, instead of just doing, I'm looking at that 3 and that 6, as those are both multiples of 3. Right? So 3, 6, or 9s or anything, or if I can combine things that make that, I can also throw that out. So instead of testing 7 plus 3 plus 6 plus 0 plus 2, right? 3 is a multiple of 3 and 6 is a multiple of 3. All I'm going to do is the last two, 7 plus 2, which is 9. And again, since this is divided by 3, right? The original number is. Okay. So that can be really quite handy. All right. Now, I want to take a look at one other one. Is so 1, 1, 5, 6, 3, 0, 5 divisible by 3. Okay. Right. So here's one of the things that I would look at with this. Again, I can add those up. It's not too bad. But that's divisible by 3, so I can just cast it away. That's divisible by 3, so throw that out. And then I'm going to look at 1 and 5 is divisible by 3. Right? So that I can throw out. And what am I left with? 1 and 5. That's also divisible by 3, right? So the answer is yes. I've basically thrown everything out and I've got 0. And 0 is divisible by 3, so it's divisible by 3. Okay, so very quickly with these you can do that. Okay. Let me also write down the 9 test, and then we'll do a couple of examples with that, and then I'll prove this. So a number n is divisible by 9 if the sum of its digits is divisible by 9. Okay. So let's look at these as well, the same two numbers. Let me write these down. Is 73,602 divisible by 9, and I want to look and see if this one is 73, oh, sorry, is 1,156,305 divisible by 9. Okay, so I'm going to do a couple of different things with this, and then we'll do a proof. Okay. So first, if I just, again, right away, just add the digits. 10 and 18, trying to get 18. So since 18 is divisible by 9, then 73,602 is divisible by 9. Okay. Okay, now the other thing that I'm going to do is I'm going to look at this and I'm going to do the same thing. The only difference is I'm going to cast out 9s. So we're going to cast out 9s. Okay, so I look at this. Let me actually just write it down again. 73,602. All right. 3 plus 6 is a, I add those together, I get a 9. I throw that out. And a 7 and 2 I add together, and I get 9 out. Done. All right. So those are gone, and those are gone. I've got nothing left. It's just 0, so then that's a yes. Yes. 7, 2 cast out. 3, 6 cast out. And one thing you can also know, even though I've got that, is, and these all work together, right? 72 is actually a multiple of 9, and 36 is a multiple of 9, so that works as well. Okay. Let's look at this one now. So 1 plus 1, 5 plus 6 plus 3 plus 0 plus 5 is, let's see if we can add this quickly. I got 3 and 6 and 1 is 10. 5 and 5 is 10, and 1 is 21. Okay, so since 21 is not divisible by 9, then 1,000,001 is not divisible by 9. Okay. That should be, again, not too bad. There's a little bit of mental math to get to that. And we know 21 is not a multiple of 9, right? Okay. Let's look at the, now let me look at this as well. 1, 1, 5, 6, 3, 0, 5. Okay. So here's what I'm going to do. So I'm going to cast out, so here's, those guys are, I'm going to group those together and throw them out. Okay. And what am I left with? Let's see. I got 5 and 5. I don't see anything that easily makes a 9. So I'm just going to do 1 plus 1 plus 5 plus 5 is 12. Again, not divisible by 9. Okay. And notice this was 9 less than that because I cast out 9 on there. Okay, so if I got something else in there that looked like it would work, I could do that. But 1, 1, and 5 don't sort of make 9s easily. Okay, so we got that. All right, so part of this is just applying divisibility. The other thing we're going to do is a proof. I'm going to prove the divisibility by 3. All right. Let's see, for and I'm going to prove it for 4-digit numbers. So neither one of these that I did as an example works, but you kind of, like once you do this, it's fairly, you can kind of see how this works. I think fairly straightforward. So I'm going to say so I've got let n be a 4-digit number. And n I'm going to write as 1000A, 100B, 10C plus D. Okay. So all that does, it pulls out the digits A, B, C. Let's take a look at that. So if I have, let's say, 4725, 4,720 plus 5, 4 times 1,000, 7 times 100, 2 times 10, plus 5. So A, B, C, D are the digits. Okay. Then here's what I'm going to do. I'm going to write 100A as 990A plus A. I'm going to write 100B as 99B plus B. 100C is 9C plus C, and D is just itself. Okay, so hopefully you can see if you combine, you should get that back. And what I'm going to do is I'm going to do, let's see, so I'm going to do 999A, 99B plus 9C, and then A plus B plus C plus D. Okay, there's the sum of my digits. That's what we're going to have. So now all I have to do is I want this to be a multiple of 3. So how do I write that as a multiple of 3? Well, 3 times 333. Oops. Right, I'm writing 990A as 333A times 3. So if you do that back, you should understand that. 3 times 33 is 99. 3 times 3 is 9. Plus A plus B. C plus D. All right. Since we call this A here, since A is divisible by 3, then n is divisible by 3 if and only if A plus B plus C plus D is divisible 3 using divisibility lemma. Okay, so even though this was a little different in terms of the other ones that we've done, we were looking at like the last digit or the last 2 digits. Okay, this one is the sum of the digits. So what we do is we write down the number in such a way. I'm pulling out the I'm pulling out the sum of the digits, right? And then what I'm left with is automatically a multiple of 3. Okay, then I've got 2. I'm writing my number n as 2 numbers. One of them is exactly divisible by 3. And so by the divisibility lemma, we basically know that n is divisible by 3 if and only if this is divisible by 3. Okay, so that wraps up this. I'm going to do 11 in the next video, so we'll cast out the 11 here.